Let's analyze all the problem in stop and wait protocol. Stop and wait protocol is a basic, initial and simplest protocol. When we resolve all the problems in stop and wait protocol, these problems will never occur in advanced protocol like sliding window protocol. Let's see all the problems one by one. There are three problems in stop and wait protocol. First problem is data packet lost. When sender send data packet to receiver, receiver receive data packet and send acknowledgement to sender. When sender receive acknowledgement, sender send next data packet. Okay, what happens if this data packet, next data packet is lost in traffic due to some network problem? Receiver do not receive any data packet after data packet 1. So receiver do not send any acknowledgement. Okay, and sender do not receive any acknowledgement after this previous acknowledgement. So sender do not send any data packet. What happened? Everything is going to be halt. Everything is going to be stopped. The whole data transfer process is going to be halt. So to overcome this problem, we introduce a term called timeout timer. Timeout timer is a time duration. We applied this timeout timer sender side. When sender start sending data packet, the timeout timer automatically start. And timeout timer, here is the point where timeout timer will expire. Before expiring timeout timer, sender must receive the acknowledgement. If sender do not receive any acknowledgement in this timeout time period, then sender automatically resend this previous data packet. Okay. This timeout timer is for data packet, this data packet. Okay. So when timeout timer expire, this is the whole timeout timer period. In this timeout time period, sender must receive the acknowledgement for this data packet. Receiver receive this data packet, send acknowledgement. Sender receive this acknowledgement packet before expiring the timeout timer. Okay. So sender must receive the acknowledgement before expiring the timeout timer. Timeout timer must be greater than. Point is the timeout timer must be greater than total time. Means time to send the data packet, put the data packet into the link, means total time is transmission time plus propagation time. Means transmission time plus round trip time, means propagation time of data packet and propagation time of acknowledgement must be greater than this total time period. Then sender start sending data packet, next data packet. When sender start sending next data packet, the timeout timer of this data packet start. Suppose this data packet is lost in traffic. What happened after timeout timer expires? Sender resend this data packet. So sender resend this data packet after timeout time. Then receiver send acknowledgement. Okay. So to overcome this problem of halting or deadlock, we introduce a term called timeout timer. So this is stop and wait plus timeout timer. We also called it ARQ. Stop and wait ARQ, automatic repeat request. Sender automatically send the data packet after expiring timeout timer. Second thing is acknowledgement lost. Suppose sender send data packet and receiver send acknowledgement, and suppose this acknowledgement is lost in traffic due to some network problem. What happened after expiring timeout timer? Sender resend this data packet and receiver accept this data packet. So receiver accept the same data packet 2 times. This problem is called duplicate data packet. Duplicate data packet problem. To overcome this problem, a simple mechanism called sequence number. We applied sequence number to data packets. There is sender, the receiver. We apply sequence number 1 with data packet 1. D. Receiver receive this data packet. Okay. Receiver send acknowledgement, and this acknowledgement is lost. After timeout timer, sender resend this data packet 1, and receiver reject this data packet because receiver knows, this time receiver knows that this data packet is duplicate data packet, and receiver send acknowledgement. Receive acknowledgement and send data packet 2. Okay, so this is the problem. Acknowledgement lost means duplicate data packet problem. To overcome this problem, we introduce stop and wait plus sequence number with data packet plus timeout timer. Okay, let's see the next problem. Third type of problem is delay acknowledgement. In delay acknowledgement, let's analyze this. Sender send data packet D1. Receiver send acknowledgement. Suppose this acknowledgement is lost in traffic due to some network problem. So what happens? After timeout timer expire, sender resend this data packet D1, and receiver reject this data packet because this is a duplicate data packet, and receiver sends acknowledgement. Sender send next data packet D2. Let's suppose this data packet is lost in the traffic, and somehow this acknowledgement is received by the sender at this point, means before expiring the timeout timer. So what happened? Sender assumes that data packet 2 D2 was successfully received by the receiver, and sender sent data packet 3, and receiver received this data packet. Why? Because this is a new data packet. This is not a duplicate data packet. So one packet is missed. So this problem is called missing packet problem. Okay. So to overcome this problem, the mechanism is very simple. Introduce sequence number with acknowledgement. So let's see. Data packet 1 and receiver send ACK with the acknowledge sequence number of 2. Why 2? Because acknowledgement always hold the sequence number of next data packet. When receiver receive data packet 1, so acknowledgement of data packet 2. Suppose this acknowledgement is lost, and after timeout timer, data packet D1 resend by the sender, and receiver reject this data packet and send acknowledgement 2. Now sender send data packet 2 and receiver, and let's suppose this data packet is lost. Okay, and somehow this acknowledgement is received by the sender at this point. So sender, what happens? Sender reject this acknowledgement. Why? Because sender already received acknowledgement number 2, and sender expect the acknowledgement number 3. Because sender send data packet 2, Sender expect the acknowledgement number 3 and sender receive the acknowledgement number 2. Sender reject this acknowledgement, and after timer expire, senders resend the data packet 2 and receiver receive it, and receiver send ACK3. So how to overcome this problem? Introduce sequence number with acknowledgement. So timeout timer plus sequence number with data packet plus sequence number with ACK. So these all three mechanisms add with stop and wait protocol to overcome all the problems. Okay.